Hello, this is James Markey from New Jersey City University. I am a doctoral student in the Educational Technology Department, and I'm going to be talking about the inferential statistic Pearson's correlation coefficient, or for our purposes here, the R, which is dealing with a sample. Pearson's correlation coefficients, or sometimes identified as Pearson's R, identifies a linear relationship between two variables. When we discuss these variables, we identify them as x and y, and we attempt to measure the linear correlation between x and y. Another term that we're going to familiarize ourselves with is bivariate data. And one of the reasons why we're going to discuss bivariate data is in Excel or SPSS, this is one of the areas where we can kind of calculate the Pearson correlation, and we'll go through the bivariate data. So if you look at the term, bi meaning two and variate meaning another term for variable. So when looking at bivariate data, you can see that it relates to two variables. So where is the correlation? And then the next step is going to be, is it a positive or negative correlation or no correlation at all? So when the calculations are done, we're looking for P to be less than 0.05. And this is going to be an indication that there is a strong correlation between the variables. So again, the next step here is we're going to have our data set, and we're going to be able to calculate that data for Pearson correlation through SPSS and Excel. We have an image here where it's going to show us the positive correlation, negative correlation, or no correlation. And again, you're looking at each of these scatter plots from left to right, and you're going to see that progression, and you can actually see on the positive one the linear, the line going up, the horizontal line for no correlation showing no progression either way, and the negative line going from left to right down. So now the value of the correlation can range from -1 to 1. And now when we calculate our data in SPSS or in Excel, we're looking for a higher number in order to establish that strong relationship. So 0.90 or above would indicate a very strong correlation, where a number like 0.40, for example, would indicate a moderate positive. So it's not that strong of a relationship. The relationship could be there, but there's also the possibility that it's not. So our next video is going to actually include our data set, and we'll actually be able to see what we need to do in terms of our data. So I'll just show you the data set here. This is the adaptive learning minutes that a student was on the system, and then the grade level math average that they finished with. So thank you, and we'll begin part 2.